everyone, and welcome to the American Society for Microbiology's Microbes After Hours program. Thrilled to see you all here tonight. My name is Ann Reed. I'm director of the American Academy of Microbiology, which is the little part of the ASM that produces the reports upon which this evening is based. You might have seen out in the foyer report an FAQ called "If the Yeast Ain't Happy, Ain't Nobody Happy," about the microbiology of beer. The American Society for Microbiology is a society that's over 100 years old. It has almost 40,000 members. That may sound like a lot, but microbiology touches everything. In fact, if we have one take-home message for you, is that microbes are everywhere, microbes are essential, and microbes are extraordinary. And you already know that microbes are important for making beer, especially if you got a t-shirt because you had to answer a question to do that. So I want to waste no more time introducing our speakers tonight. You may think that there are a lot of things wrong with America. But once you know that we have an Anheuser-Busch endowed professor of malting and brewing in this country, it's not so bad, right? So I'm thrilled to introduce Dr. Charlie Bamforth, who was on the steering committee for the meeting that produced the report. And he is the Anheuser-Busch Endowed Professor of Malting and Brewing Sciences and Distinguished Professor at UC Davis. He's been part of the brewing industry for over 35 years, formerly the Deputy Director General of Brewing Research International and the Research Manager and Quality Assurance Manager of Bass Brewers. Charlie is Editor-in-Chief of the Journal of the American Society of Brewing Chemists. Bet you didn't know there was a Society of Brewing Chemists. But there is, another good sign. He's on the editorial boards of several other journals, and he's published many, many papers and articles and books on beer and brewing. And in his downtime, he writes about soccer. I can't come up with a microbiological connection to soccer right off the top of my head, but I'm sure there is one. Maybe you can come up with it. In 2011, Charlie was honored by the Award of Distinction from the American Society of Brewing Chemists for exceptional contributions and long, diligent service to brewing science and the brewing industry, for which we must all be thankful, all of us who love beer. He's also been honored by the students at UC Davis as one of the top 3 educators in his college. So please welcome Charlie Bamforth.
Well, thank you very much. It's nice to be here. It's also very damp. And I'm also conscious of the fact that later on this evening, the Oakland A's are going to defeat the Detroit Tigers. So I won't hesitate by moving on and talking about beer. By the way, yesterday, St. Louis Cardinals, one of my former students playing for the St. Louis Cardinals, so Daniel Descalso, if that was of interest to you, particularly if you're a Pittsburgh fan. Let's talk about beer. How is beer made? Beer, of course, is the finest alcoholic beverage on the planet. People talk about wine. You get a bunch of grapes, tread on them, wait. And what you do while you're waiting, you drink beer, which is much more complicated, starting, of course, with cereal. The main one used globally is barley, and the first thing you have to do with it is to malt it. Otherwise, you will not get good extractable material. So it is steeped in water, and then it is sprouted for several days and dried. And when you dry it, you produce a range of different colors and flavors, depending on the intensity of drying. Then it is stored for 4 weeks, and then it is ground up and mixed with hot water and mashed, and then goes to a fermenter via a boiling stage with hops. You introduce the hops to provide some spice and flavor to the product, and then you cool it down and ferment, which of course is where the yeast comes in, and then downstream there is some cleaning up to be done and some maturation, and then you package this absolute nectar, which is generally described as being like an angel weeping on your tongue. When people talk about beer, of course, when they think about microbiology, they think primarily about the yeast. But of course, microbiology has a huge role to play throughout the production of beer, starting with the raw materials in the field. And one of the big scary things that brewers worry about is fusarium contaminating the grain. Fusarium which will contaminate the grain, particularly in the damper, colder places, miserable places like Scotland. I'm English, so I can say that. And if it gets damp, then it's prone to contamination with fusarium. And there are two things we worry about. The first of these is hydrophobin. Hydrophobin, as the name suggests, is an intensely hydrophobic polypeptide or peptide. And if it gets into the beer and you open the beer goes whoosh, which of course is gushing. Now, the gushing may be because your friend's a complete idiot and has shaken your beer, but if he or she has not shaken your beer, then chances are it may be due to this hydrophobin coming from the fusarium. Now, that's bad enough to worry about, but we would worry a lot more about deoxynivalenol, DON, otherwise known as vomitoxin. Everything's in the name. And so we really don't want this stuff to be in beer. It's interesting that a few years ago, or several years ago now, fusarium did rear its head in North America. And that was when the burning of straw in the field was outlawed. And people said, it's not a good idea to set fire to fields, but the good thing about setting fire to fields was you killed off any incipient fusarium. Now, some people will spray and will use herbicides to protect against this sort of thing, but most brewers are really keen to have really clean labeling and clean products, and they're not desperately keen on the use of those materials, but they may have some advantages. It's a toss-up between which is more desirable, a herbicide or something like deoxynivalenol. Hops, the spice of beer. It's the most beautiful thing in the world. The flowering species of the flowering plant of the female of the species. The world of hops is a miserable place for the male because there are male hop plants and female hop plants, and if they get together, you dim the lights, play some music, you get seeds, and that is bad news for beer quality. So the hops are the flowering body from the female of the species, and they are very, very susceptible to various things. I'll just show a couple of them here. One is verticillium wilt. That can wreak havoc in a hop yard. So too can powdery mildew. And so microbial spoilage of the raw materials is not an insignificant thing, and we need to avoid it. Water. By the way, there is a T in the middle. It's not water, it's water. And the water itself can have a microbiology all of its own, of course, and we worry about them. The second one here is Legionella. I remember when I was research manager for Bass, one of our Bass breweries was in Glasgow, right next to a hospital. People went into the hospital to get better. They did not expect Legionella to be funneled at them from the brewery cooling tower next door. So the cooling towers in breweries are a risk, and brewers need to be mindful of keeping these in the appropriate condition. Spore formers. I remember a specific incident when I was with Bass. We were selling an alcohol-free beer called Barbican in Saudi Arabia. I'm not quite sure how we managed it, but we were selling an alcohol-free beer in Saudi Arabia. And Allah was very displeased on one occasion because they detected bacteria in the beer. They were in fact spore formers. They were bacillus from the water supply. Our microbiological checks in the brewery were fastidious in making sure they were appropriate to the product. And therefore we included a medium, or used a medium that mimicked the beer, and therefore we'd only detect those organisms which would spoil the product. In Saudi they were using a general method that would detect anything. We thought we were doing the right thing, but the method has got to match what the customer expects. So this is yeast, Saccharomyces, of course, and of course it reproduces in a brewery by budding. All these lovely daughter cells, you can see these bud scars where the daughter cell grows off from the mother cell. And the more bud scars there, the older the yeast is, the more senile the yeast is. So the yeast is very, very important. And of course, the first guy to really come up with pure yeast culture was this man, Emil Christian Hansen, working at the Carlsberg Company. Until that guy, working in the last decade of the 19th century, which is pretty close to when the work of Pasteur and Cagniard, Latour and so on actually convinced the chemists finally that microorganisms are responsible for making beer. Up to then, they thought it was a pure chemical reaction. But very soon after, Hansen was the first guy to come up with pure yeast cultures. Up till then, what people did basically was backslopping, which was taking the yeast from one fermentation, recovering it and putting it into the next. And of course, in the Middle Ages, yeast was known as God is good, because nobody knew what the heck it was. All they knew is you put it into the next batch. And indeed, God is good, because it is kicking off the production of beer. What Christian Hansen did, Emil Christian Hansen, was to dilute the yeast to produce a single cell and then multiply it to produce these daughter cells. And so we had then pure yeast culture and much more consistency, thanks to all the beer being produced from a single yeast. This rapidly went around the world. Everybody accepted it except the British. The British insisted that you needed two yeasts. You needed the primary yeast for fermentation, Saccharomyces, but you also needed a second yeast to introduce consistency into the product and conditioning into the product, and that was given the name, in honor of the British, Brettanomyces, which gives the delicious aroma of tomcat urine and wet horse blanket and so on into the product. Of course, we can divide the yeast into two categories. We can divide them into ale yeasts, which of course are top fermenting yeast, which given their druthers will rise to the top of a fermentation, and lager yeast, bottom fermenting yeast, which tend to migrate to the bottom of the fermenter. I tell my students at UC Davis the way to distinguish them is to look at the name of bottom fermenting yeasts, Saccharomyces pastorianus, take the last four letters, and you know you have bottom fermenting yeast. Lager fermenting yeast is much more complex, rather more complicated than ale yeast. And indeed, my colleagues and fellow professors in the world of brewing, most of whom are yeast people, I'm not, I'm a barley person really, they insist that lager yeast cannot be readily isolated from nature. But there is a recent study that was published that takes us down to Patagonia, where they reckon that they have isolated the forerunner of the lager yeast. And this, the theory goes, was a meld of Saccharomyces cerevisiae with Saccharomyces eubayanus. And that accounts for the extra DNA, the extra genomic material which is present in the lager yeast. Ale yeasts have been isolated globally. So there are very few, relatively speaking, lager yeasts. And as you'll have seen from reading the booklet or looking at the posters outside, lager yeast prefers a cooler temperature, and yet lager yeast is differentiated from ale yeast by its ability to use the disaccharide mellibiose, because the lager yeast has got an alpha galactosidase, which is not present in ale yeast. So there are many yeast strains. I love to tweak my fellow brewing professors, because as I say, most of them are yeast people, and I insist that the malt and the hops is more important. And if you get a really intensely flavored product full of roasted character, for example Guinness, of which there are more myths than any other beer in the world. A woman emailed me and said, is it true the difference between Guinness brewed in Dublin, Guinness brewed elsewhere, where is they marinate a dead cow in the beer in Dublin? I said, I've never heard anything quite so stupid. Everybody knows it's a sheep. But if you take an intensely hoppy flavor and so on, the contribution of the yeast is less important than it is in a gently flavored North American lager. But the yeast can make a huge impact on the quality of beer. And of course, we can talk about beer quality in various headings: foam, color, the clarity, flavor and flavor stability, gushing that we've already talked about already, and wholesomeness. And of course, everybody knows yeast is damn good for you. Yeast can actually jeopardize the stability of the foam on beer, and everybody agrees, of course, because you're all civilized and you all put your beer in a glass, that the foam is important. If the yeast autolyzes, it jeopardizes the foam. Many of the larger brewers do something called high gravity brewing. What you do is produce an extract of the malt, the wort, which is more concentrated than you need. And you ferment that, therefore you produce a higher alcohol level, and then you add water downstream to maximize the beer throughput from every fermenter. But that is bad news for beer quality, because it stresses the yeast, and the yeast responds by making an enzyme called proteinase A, which chews up the proteins from the grain, which are responsible for foam. And also, there is foam polypeptide that are lost with the yeast, which is collecting on top of a fermenter, and shorter chain fatty acids, things like caprylic acid and caproic acid, they can damage the foam as well. Yeast has some influences on beer flavor, and the most insidious, of course, is vicinal diketones, VDKs, notably diacetyl. Diacetyl is produced in every brewery fermentation. That's the bad news. The good news is the yeast takes it away again. But you have to leave the yeast long enough with the beer for the diacetyl to be removed. Otherwise, you get the delicious aroma of popcorn and butterscotch, which is okay in Chardonnay, but it ain't no good in a lager. VDK actually also can be contributed from Pediococcus, which is one of the organisms that can contaminate dispense lines. So if you go into a bar, particularly one that's got lots and lots of beers on tap, and they don't look after those pipes, then you're going to have a risk of Pediococcus, and your beer will taste like drinking popcorn solution. Not a good thing. Higher alcohols, esters, sulfur-containing compounds such as dimethyl sulfide, which is, of course, the type flavor in Rolling Rock Lager, short-chain fatty acids, and acetaldehyde, all produced by the yeast. One yeast, the heifer yeast, which is the one used for Hefeweizen, the ideal breakfast food, this actually produces an enzyme which will decarboxylate ferulic acid and give the delicious aroma of the clove. If you don't have that character, it ain't authentic in your Hefeweizen. Here's Brettanomyces. These days, very popular in spontaneous fermented beers. My favorite of these breweries is Russian River. Vinny Cilurzo is a very good friend of mine. I went to see him, and he confirmed what he'd said. If used properly with Kerry, can add rich aromas and flavors of earthiness, leather, smoked barnyard, and our favorite descriptor, wet dog in a phone booth. But of course, many of these, of course, feature, and this type of organism, and many others, of course, feature in the lambics, beers made in Belgium, spontaneous fermentation, and of course, one way to protect against the really sour character is to introduce fruit. And this is Pêche, which is, of course, peaches, and there are a range of others as well. There are many organisms, no pathogens will spoil beer. My dear friend and colleague Linda Harris is here. She and I can never work together because she only works on pathogens and I work with the healthy food stuff. And of course we can divide the bacteria, of course, by the classic gram staining, and you can see for yourself the range of organisms that have been referred to and can be an issue with the contamination of beer. But of course, if it's something like a lambic, it ain't contamination. It is, of course, an opportunity. And talking of opportunities, what can we do with the surplus yeast? Of course, in England, you either love or you hate Marmite. Depends on whether your mother abused you as a child. If your mother gave you Marmite, you adore it, such as my wife. If your mother did not, you hate it, such as me. So my wife and I never have a cuddle and an embrace after she has been eating Marmite. And it can actually create all sorts of mess. Thank you for your attention.
We will have an opportunity for questions after our next talk. I forgot to say that these talks are live streamed over the series of tubes that is the internet, and they are also recorded and kept in our archives. So if you missed any of what Charlie said, you can look it up later. And I just want to say hello to people who are watching online and the audiences of the future who are maybe watching this talk years from now. I'm just really excited that now I can say I write booklets. Booklets. There are many other words I want to learn to say, but that's an awesome one. So let me introduce our next speaker. Rebecca Newman has been a brewing professional for nearly 30 years, or since, I guess, middle school. She graduated from UC Davis with a bachelor's in food science and technology. When she graduated, she was recruited by Anheuser-Busch, where she learned about beer quality for brewing and packaging. After a stint in sake brewing, our next FAQ, analysis and lots of tasting, she returned to beer about 15 years ago, I guess. She was invited to join Sierra Nevada Brewing Company, and while she was with them, she created their quality program. I hope none of you drank Sierra Nevada before then. Through her mentor, Dr. Joe Awadi, she met Jim Cook, the founder of Samuel Adams. And before she knew it, she was working for him, and she'd moved to Boston and directing multiple quality sensory research and innovation projects. From Boston, she returned to the West Coast, working with several craft brewers. It wasn't long before she met the folks at Dogfish Head Craft Brewery and accepted their quality position. She's worked with a lot of talented people. She's had great mentors, and her love of good beer has taken her around the world. So welcome, Rebecca, and we're looking forward to hearing more about your career.
Hi, and thank you very much for having me tonight. I wanted to just bring a couple of props so you know what the typical ingredients of beer are. These are hops. We opened them only a little bit because they're incredibly pungent. If you look at the bag, you'll see they look like little tiny bath oil beads. That's the lupulin. So for those of you that know anything about hops, these were last year's crop. They've been in refrigerated storage. They're still very, very fragrant. I'm going to pass these around.
What variety?
I'll tell you, I know. Those are 644, so we brought some beer tonight, and sorry for everybody that's out there in the ether world that you didn't get to taste. We brought the American Beauty beer, which is showcasing the 644 hop. It's very bright, it's very light, and then I brought some malt. So this is just 2-row pale malt. Typical beer is made with hops and barley. Hops are bacteriostatic. So to microbiologists, you're like, yay, keeps the bacteria down that we don't want growing in beer. What we don't want growing in beer are the microbes that spoil beer. So I'll get off the Marmite here. I'll go to me. All right, yay, woo, it's all about the yeast. I am a quality professional. I am not a microbiologist. I suggest anybody out there now, in the future, whenever, if you're looking for a job in microbiology that's very challenging, go to a brewer's website, look on their careers page, and see if they're looking for a microbiologist, especially in the craft industry. We're looking for people that are like-minded, thinking outside the box, bringing in ideas from not only food microbiology, but wine microbiology, hopefully not pathological microbiology, because God knows we don't need that to happen. This is the brewery I work at. Most people see the Dogfish treehouse and they think, wow, what a fun place to work. I see that treehouse every day and I say, I am so lucky to be here. And then I look to the right and I'm like, gotta get to work. I gotta check the beer in those tanks. This is our heartbeat. This is our yeast room. So for those of you that haven't figured it out, I'm in the brewery. I am out there looking at what's going on in the fermentation. I'm checking the profile of every fermentation. All of our beers are unique in that we use up to 8 different strains of yeast. At Anheuser-Busch, they primarily use 1 lager strain. We use 1 lager strain, but we have 7 different ale strains. This is our yeast room. You can see that it's very technologically current. We have beautiful cone bottom stainless steel tanks. We have manifolds with automated valving. We have sight glasses, so you can see to the one side where there's a light yellow looking color. That's our circulation of the yeast. So we're actively circulating the yeast so that we maintain our yeast in a lively form, so we can pull it right out of the brink and put it into the fermenter, and off we go. More stainless steel. Breweries now are investing in really great equipment. Used to be that it was wooden tanks, it was repurposed dairy equipment, especially among the craft brewers. It was whatever they could get their hands on to make beer. Now breweries are looking at pipe fences and pumps and getting away from hoses. As a microbiologist, we are looking at where the microbes hang out, not just the yeast that were used in fermenting, but beer spoilers. Beer spoilers are primarily Pediococcus and Lactobacillus. This is the dark, dank recesses of our wood room. For anyone that knows Dogfish Head Craft Beer, we have the Palo Santo Marron wood tanks. It's the only tanks in the world that we put beer in to age. It is heavier than most woods. It sinks like a rock. It does not float. And if you are fortunate enough to come visit the brewery and you get to see the wood, if you scrape it or if you had a piece of sandpaper, there is so much limonene and chlorophyll in that wood that the sawdust is turquoise. It's just incredible. We also have barrels where we do secondary aging, not fermentation, but aging, and that's when we'll introduce Brettanomyces. Brettanomyces for those wonderful flavors that Charlie talked about a little bit ago. This is the contrast life that I lead. This is 2 brew houses we operate. We have one brew house that was from an older brewery that we put back together in our Milton brewery. It's the one to your right. Everything is added manually. Every one of those sight glasses is able to be opened, and the ingredients are poured in by the brewers. If you look to the right, we've got beautiful windows, we've got nice cedar paneling, and everything now is automated. Those are 100-barrel vessels, brand new. We're just commissioning now, so if you haven't come seen the brewery in the last 6 months, please come see us. You'll see lots of change. The reason I'm spending so much time talking about how we brew and what we brew is because our ingredients are not just hops and barley. We use many culinary ingredients. And how do we get those ingredients in now? Well, the lower portion of the slide is our malt mill, where we hydrate the grain so that it doesn't splinter and shatter, and we think that the flavor of the beer is fuller. Behind it, more stainless steel, you'll see vessels that are injector ports for the various culinary adds. We use Belgian brown sugar, we use strawberries, we use apricots, we use cilantro, we use apples, we use lots of different ingredients. And for those of you that got to taste the Midas tonight, we even use saffron, honey, and muscat grapes. So be careful with that one. It's a little bit high alcohol, about 12%. This is the brewery that I was talking about, the new brew house. You can see there's a little hoop coming into the vessel. We pump everything in now. No more opening the manway and dumping it in from the shoulder level. If you look to the top, there's an agitator. That's a mash tun. So the grain comes in with the water and there's a slow agitation. What I wanted to do is I wanted to contrast what Charlie was talking about and just kind of walk you through our brewery. If you look below, this is where I learned brewing at Sierra Nevada. This is the bottom of the lauter tun, and if you look at it, it looks like a stainless steel octopus. And for those of you that are home brewers or you've been in a brewery, this is where the liquid called wort funnels down through the grain and, oopsie, oh, don't know what that means. Did I do that? Okay, anyway, so that's the mash tun. Below that is the lauter. All those pipes will funnel the liquid wort, which is the sweet liquid used for fermentation. Okay, micro, yay, we finally made it. This is where we do our work. We have forced fermentations with their foil on the tops. There's a shaker table. We're looking at how well our brewers made the wort. Did they make it to the specification we were looking for? In the refrigerator, we have a multitude of media that we use, primarily HLP, SDA, SDAA, LCSM, and LWYM. For anybody that wants to look that up, just do a Google search on micromedia beer and it'll give you lots of great information. This is Katie. Katie came tonight. Katie sits at the micro. She's always doing direct microscopic observation, looking to see if anything that shows on a plate could, in fact, harm our beer. More we're worried about our flavor profile going out of balance. From time to time, it happens. You get a wild yeast. It can come in with your raw materials, especially if you dry hop or you dry spice post the brew house, because in the brew house, you go through a pasteurization pasteurization process or a boil. So we're always looking at every single tank. Every single tank gets tested at least twice, once during fermentation and then post-dry hop. We also use a tube that's a facultative anaerobe. It starts aerobically and then it goes anaerobically, primarily looking for PDO or lactics. And then this is when we get to heaven. This is beer in the package. This is what we send to our consumer. We just are now, in fact, today we ran our second acceptance test for commissioning our line. We're very proud of it. We're very mechanized. And we run at 650 bottles a minute. That's a big deal for a craft brewer, so I wanted to share with you that. This is a fun part of my job. Like I said, I work in quality. This was a beer lineup we did. We have multiple styles of beer, different colors of beer, and we do lots of innovation, so we're doing blending. We also have a sensory department where we'll put our panelists to the test and see what they think about the beer. If the beer doesn't taste good, it doesn't get released and it will not be sold. This is our beer library. This is our new beer I just brought tonight. I hope you guys had a good time with it. We keep a beer library which is similar to Retain's, so we can go back and taste against any consumer concern that comes through, or just to see how our beer is aging. This makes me very happy, pairing food and beer. Charlie, there's some lacing in the glass there. This is the best part of the day, when you get to the bottom of the glass. Thank you very much.
We have handheld microphones, so you guys can just be out there and get you a mic. So we can take questions now. I do ask, if you have a question in this room, that you go up to the microphone so that the people online will be able to hear you. And we'll also have questions run in from the other room. And we can accept tweets. Shannon, is the tweet address somewhere for people? I'm just showing off.
They can tweet to @microbeworld.
Okay, @microbeworld. And over the web, by email as well? No, okay. All right, so those are all your options. You can either be in this room, you can be in that room, or you can tweet. Okay.
So what happened to the species name Uvarum?
Well, you know, taxonomists keep changing names and so on, and of course it all is all to do with theft. The very first, before all this stuff about Patagonia, people generally felt that, you know, the first lager yeast somehow arrived in southern Germany. And then a country that should remain nameless, the Czechs, stole it, and they took it to there and made some of the great Pilsners. And then the Danes stole it, and they put their own name on it. That's really being cheeky. And still, if you go to Denmark, they'll still call it Saccharomyces carlsbergensis. And then they said, oh, well, no, it's not that. It's really Saccharomyces juvarum. And then we went through an iteration of saying, well, it's Saccharomyces cerevisiae lager type. But now I think taxonomists have generally agreed that it's actually Saccharomyces pastorianus.
Of the Belgian-style beer here in the U.S., a lot of them don't get it right, except Ommegang. What is Ommegang doing that the others are not?
Well, perhaps my colleague knows, but I don't know.
They pay attention to the acid balance, and what a lot of American brewers don't realize is it takes more than just yeast to make good beer. There's an acetic acid, a malic acid, tartaric acid. They're looking at various acid additions through microbes or through a blending process. Ommegang uses really interesting ingredients. They pay close attention to their primary fermentation, and I think they do some amount of blending. So they do a heck of a job with their beers.
Incidentally, not too long ago, a student of mine called Nick Bokolich and we published a paper in PLOS ONE, all to do with the succession of microorganisms in North American spontaneous ales. You can't call them lambics in this country, but you might like to check that out.
So I have a question from Twitter that's kind of a follow-up on the yeast species question. Have these different strains or species of yeast been genetically sequenced in order to really ultimately tie down where they come from and what they are?
I don't know that they've been genetically sequenced as such, but certainly the work, the research that was done, I think it was published in the Proceedings of the National Academy of Sciences, they certainly tied it down to Cerevisiae, I believe, eubionus blend. Obviously, there has been a lot of work over the years in the sequencing of the genome of Saccharomyces cerevisiae. But of course, most of the work has been done on laboratory strains, which are haploid. Brewing strains, of course, are either polyploid or aneuploid. And so they've got a fairly complex genome.
I can talk about beer style. Oh,
Yeah, I was just
Please come up to the
wondering,
microphone.
Oh, yeah, absolutely. Hello, I was just wondering if either of you see a future for genetically modified yeast in the future of brewing, and whether or not you think that that will be accepted by brewers or accepted by consumers.
Well, back in the mid-1990s, I was research director at a place called, then it was called Brewing Research Foundation International in the UK. And we actually did come up with the first genetically modified brewing yeast which was accepted by the government. So what we did was to take a gene, the so-called DEX gene, the gene for glucoamylase, from Saccharomyces diastaticus, and we transferred it into the lager strain, and therefore we produced a yeast that would actually super attenuate beer. And we presented it, a guy called John Hammond, actually, if you've ever seen Jurassic Park, but this was a different John Hammond. And we took it to all the relevant committees in the British government.